anh hùng gì? Oh, testing. While waiting for the rest, I learn some of your name. Who is Ryan Tan? Not here yet. Ryan Tan. Lim Sui Long. Okay. There's one person similar to my name. Chu. How you read your name? Seng. Are you from JB or not? Oh, Seng. Okay. I got a JB friend also similar name. Oh, Jia Seng. Okay. A lot of Seng in our class. Dan Ziyi. Okay. Zhong Jinghua. Okay. Yeah, I guess it's you. Yeah, I forgot who is Buntat again. Oh, Buntat, okay. Ryan Tan here already. Not here yet. Okay. Welcome back to this week lecture. So, I collect a few questions for you guys. So maybe we'll present it first. So we'll make it a short tutorial section now. So our first question is, if dy dx equal to t squared, then is it the second derivative equals to 2t? Yes or no? Huh? Why? Yeah, so the variable here is different. So you cannot just differentiate with respect to t. So what are you doing here, right? Wait, let me. Okay, what you are doing here is like dx of dt t squared. Okay, so you can see that these two are different. Right? Okay, run it. Okay, so they are different variable. So you cannot do this. Okay, so what do you do? How to compute second derivative? Okay, so you use the formula, which is from the chain rule, you get that d dt dy dx over dx dt. Okay, so remember this formula here. Okay, so remember, always see what you are doing before you do, and check your variable first. Okay, any question? Any question? So check your variable. Check your variable. Okay, second is this one. Last week we mentioned that if dy dt equals to ds dt equals 0, both derivative is 0, then we say that it's a static point. Okay. The other way is correct. If it is a static point, then dy dt equals ds dt. But it turns out that it doesn't imply that if the time derivative is 0, then it must be a static point. Because last week we got this example here. So this one is the first example of today. Okay, so last time I left this as an exercise for you. Go back and do. How many of you have done it? Okay, good. If you have done it, if not, please start today. Okay. I already posted the solution up. In this case, when you wanted to find the horizontal tangent or vertical tangent, you realize that there are 2 points at 3 pi over 2. dy dt and dx dt both equal to 0. Okay. So, but this curve is not a point. What's this curve again? Anyone remember what this curve is? Is this what's this example curve? Anyone know? Is it okay, well, let me see. Anyone can recall what this curve is? You mean the curve is 1 plus sine theta? Okay, okay, yeah, okay, sure. So r equals to 1 plus sine theta. Anyone know what's the parameterized curve? What's in terms of x and y? You sure? That one is circle. Is it like 1 plus something? Okay, let me just quickly check my notes. See. Okay, it started with this. Never mind then. Okay. See again. Check again. Sure. Yeah, okay. Just start with this polar curve. Okay. All right. So at this point, what happened? So okay, let me write something down. So dy dx equals to dy dt over dx dt. Right. Okay. So 0 over 0, something weird is going on. We don't know what is going on. So what we do is we check the limit. Okay. Check the left and right limit. Okay. Yeah. Check the left and right limit. Okay. So if you check the left limit, you will see that dy dx approach to infinity. If you go the other way, it approach negative infinity. Okay. So which means both of them are straight line. Okay. But one way approach in this way. Okay. The other way approach in the other way. Should I draw it out or can you see it? Should I draw it out? Okay, let me just draw it out. So one of the way you approach in this way. Okay, let me draw more. So like this, and then like this. Okay. So this one is what is like a, so it's going from here to infinity, and then the other way is going from here and here. Okay. Okay. So here is going to negative infinity. Right. Okay. It's okay. So I mean, you start from here is the 1 over 2 divided by 6, and then here is 1 over 2. Actually, this one relies a bit on this geometry. So first we know how to draw this first, okay, and then we start from this horizontal and then we move it up. all the way to the 0, 0 origin. Any question or not? Yeah, so far okay. Okay. Just feel free to stop me. So this one is the first example. Okay. Yeah, this one also I left as a homework exercise. Please do it if you haven't started. So this is from the first lecture. Yeah. Okay. So this is a cycloid. What is a cycloid? So it is a curve traced by a point on the rim. Okay. So for example, you take this point here, okay, and then you move this wheel. Okay, when you move, you can imagine this point move out, right? Okay. But when you move up at the same time, this wheel is going front. Okay, so this point is going forward and then up. Okay, so this is tracing the wheel. Okay. So the question here is this. So you want to find this OT here. Okay, what's OT here? So first you take this point, okay, you start from here, okay, and then you move this wheel, okay. So that means this point will get moved up to P, for example, right? Okay, so should imagine the wheel is moving. So when the wheel is moving, when it moves to T, then this bottom point here will move to P. Okay, and then show that the length that the wheel moves forward is actually the same as this arc here. Does it make sense? Make sense? Okay. Okay, so I mean, it's not always true that if you take two line, okay, for example, you take two line, okay, and then you somehow bend the other line, okay, and then you draw a circle, right? I mean, not a circle, but some curve. It's not always that these two are the same, right? Yeah. But it is because of how you define this cycloid, how it moves, then the length of this arc is equal to the distance you have moved. Make sense or not? Make sense? Okay. It doesn't, it's not always true that this length is always equal to OT. Does it make sense? Okay. So I give you a very real life example. So that day I went to a restaurant and then I saw this. So this is like the tomato get sliced. Okay. So exactly, okay. So what I want to say is this part here. So let me draw it out. So this part here is the same as color is better. The arc here. So let me write OT here. Let me see what color is better. Okay, this one is better. So this one is the OT. And then this part is also OT. Okay, makes sense. Makes sense. Okay. Okay. Although this is not a perfect circle, but the idea is there. Okay. Next. Okay. Third is this. Last time I make some wrong comment. Some of you come and ask about it. So I make this full summary here. So this one is the third. The problem. Okay, so first if you think too many stuff here, never mind, you just follow what I said first. So at first, you can explain the everything in this diagram here just using positive R and positive theta. Okay, right? So positive theta is a is an anti-clockwise from the positive axis. Okay, so 0 to 2 pi. Okay, so this is positive theta. And then because radius is always positive. Okay, for now, right? So because you are going forward everywhere, right? So this is r theta. But if you fix an r theta, okay, or r anything, r an angle, if you take a negative, we define it to be the opposite of this line here. Make sense? Okay. So here I summarize all the relation between uh, r theta minus theta, minus r theta or r minus theta or minus r minus theta. Okay. So this link everything together. You welcome you to check this and then try and see if you can compute the right thing. Okay. So basically, for any one point, right, you can write it in four forms, in these four forms. Okay. And yeah. So what differentiates these four forms is how many negative you have. Okay. You can describe the point as fully positive one, negative in any position, literally. Yeah. If you don't get this picture right, just pick a specific one. Maybe pick 230° or 2 pi. Okay. Also, I get a question say, do we need to use radian or degree? Right. Okay. So we prefer radian. Okay, use radian. Yeah, radian. So use pi those. Okay. And whether you need to memorize formula or not, for now, yes. Sorry about that. You need to memorize the formula, all the formula for now first. Okay. Because yeah, depend on other lecturer whether they want to release formula sheet during the exam. But for now, please memorize first. Okay. Yeah. I mean, instead of memorize, right, you should get used to those formula. At least for this semester. Okay, for this semester. So yeah. Okay, next fourth problem here. Okay, so last time we start about Cartesian product, polar product, and so on. So I fixed the definition here. Okay, so the very first thing we do, right? Okay, if you're confused with all these pictures, follow what I say first. So for the very first thing we do is we do Cartesian coordinate on XY plane. Okay, so our X and Y coordinate are is labeled by XY. Okay, and then we call it a Cartesian coordinate when we use the XY variable. And then towards the second lecture, we still stuck with XY plane, but we use a different coordinate. Okay, we use radius and theta. But what you label here is still Y and X. Make sense or not? It's just how to say you're still living on the same land, okay, but it's just a different name. Okay, let me think how to say. Okay, I know how to say it now. Okay. Okay. So for example, let's take one point here. Okay, for example, we take one point here. Okay. This is 1, 0. Oh, sorry, 0, 1. Okay. So in Cartesian coordinate, it's 0, 1. Okay. Also take the same point here, 0, 1. But here now in polar coordinate, it have different name, which is 1, 0. This is r theta. Okay. This is x1. To who? What? Oh, sorry. This one is also. Oh, then this example not good, right? This example not good. Okay, so let's change another point to make you see it really clear. So let's maybe pick a different one. So let's pick bottom one. Hey, sorry. Okay, let's pick a bottom one. Just now it has the same name. It's a coincidence. So now let's pick this one. So this one is -1. Sorry, 0 -1. Okay, 0 -1. Okay, now correct. So how about here? This 0 -1 will become 1 3 pi over 2. Okay. So you have a different name, but you still live on the same plane. Okay, make sense? Okay, so that's why even though we change, okay, these two are both circle of radius 1 center at 0. In the x coordinate, Cartesian coordinate, it is x squared plus y squared equals to 1. But in polar coordinate, we just use r equals to 1. And then one benefit of using polar coordinate is, you see, x squared plus y squared equals to 1 is not a function. Okay, but if you turn into a polar coordinate, it becomes a function. Okay, so there's some advantage when you switch between coordinates. Okay, some curve which is not a function become a function. And then what? And then we like function. Okay, because we can do more things with function. Is it clear? Clear? Okay, so also another question is in the middle of sketching the polar graph, right? We look at this r theta plane. Okay, r theta plane. So if we focus on this square here, okay, just now we focus on this square. Let's focus on this square now. So we focus on here, okay. If our SY coordinate become r theta coordinate, then r equals to 1 is just a constant line. Make sense? So for every theta, it is r equals to 1. Okay. Yeah. Power coordinate in r theta plane. Okay. R theta plane. So you can see that really, what is this square here? What is this? Sorry, what is this circle here, right? So this circle here is you take this infinite line, and then you loop around this circle. Make sense? Make sense or not? You take this line here. The relation between these two planes, right, is you take this line here, okay, and then you loop around this circle. Okay. So let's say I want to do one full cycle. What interval should I take? 0 to 2 pi, yes. Okay. So if you take 0 to 2 pi, okay, you just cut it here, okay. So you cut it here, and then this line here will form this one full cycle here. Okay, make sense? Okay. Otherwise, you will keep looping. Yeah. Okay. So let's fix this one. Maybe we talk about this symmetry next time. Okay. Maybe we talk too much today. Another thing I want to show you is yeah, this my last so let me talk about this last question before we jump into today's content. We talk about this symmetry tomorrow, okay? Symmetry tomorrow. So talk about this fifth problem here. So in the last lecture, I said I challenge you to change this into a Cartesian graph. put into XY and then try and compute it. Okay. So I also posted this actually. So first one who approached me is Yi Sun, right? Yi Sun. Okay, pronounced right. Okay, Yi Sun. So this one is what I initially thought. Okay, this solution is what I thought. Okay, so he did it. He partially did it, and then he used software to solve it. I managed to change variable, and then I also use software to solve this integral because this integral seems too ugly. So if you can solve by hand, you let me know. Yeah. Okay. So what do you do? So first you start with this polar curve, right? Turn it into an XY coordinate. Okay. So this is what I did. Okay. He also did similar stuff. So this is what I did. Okay. Then we get this y square plus this junk here. Okay, s square plus some square root term here. Okay, so you see, you have square on both y and x. So this is not a function. Okay, so we cannot integrate over function for now. I mean, so we find y in terms of x first. So this is this square root bizarre stuff. Okay, and then I try to integrate this guy. Okay, and then I do a few substitution until this stage is still bizarre. Okay, so I decide to use software. So this is not cheating, but I'm suggesting you can use Ufen Alpha or Symbolab if you're stuck on some integral. Okay, so for you to find some hint, okay, instead of just doing it. So I mean, for this, right, I spent the whole evening doing this afternoon. I mean, so yeah. So it turns out to be the right answer, so it's good. And this is the Cartesian graph for that circle. So this one, this is the Cartesian graph. But there's another solution posted by I think both Hong Yu and Jinghua, right? Jinghua sent me the similar answer. So they write they they write this question into a parametrized curve. Okay, so they write into parametrized curve. So they find what is x in terms of theta, y in terms of theta, and then use this to find this area here. Okay, use that formula. You remember the formula? Where's the formula? Here. Yeah, here's the formula. GT f prime t dt. Yeah, they use this. So there are two graphs they draw. First of all, y to x graph should be the same. Okay, this is what we discussed just now. In the xy plane, you are just using polar coordinate or the xy coordinate. Okay, so they should be the same. Somehow they also draw this y versus theta graph. Okay, I think it's quite nice here. So you can see how y changes against theta. So you can see that this curve here, you can loop around this circle here. You can see it. Take this y here, and then you join this 2 pi back to 0, which is how you get this point. Okay, anyway, so this is the integral. This is the method to find, and then this is the graph. Okay, I'll pause it up for you to see. So you can see that there are different ways of solving one question. Okay, yeah. So typically we want to skip this integral in the class because it's too tedious. So make sure you know how to do this. Do at home. If you get stuck, you just message me, and then we'll see what's going on. Okay, so do it at home for the integral. Okay. Any question or not? No. About okay. Seems like some of you already get lost. I mean, yeah, you should do more exercises in the tutorial. Okay, please do exercises in the tutorial. And yeah, all right. Yeah. Maybe just take a 3 minutes break first, drink some water, then we will have a fresh start. Yeah.
就是你说解这个，
你说你继续说。
你解的
Yeah
可以用那个
什么？
三角还原，
可以，好像但是要做很多次哦，
只用一次就可以了。
一次就可以了。你试下，你做下给我看。你做出来，你做出来给我看。I think your class is by far what I see is most active, both in class and outside class. So I think will be a good class. So please for the rest, if you get lost, right, please catch up. Yeah, please catch up. Okay, you really need to work really hard, I think. Yeah, please catch up. Please don't give up.对，
这两个是那个 x y 平面，这两个是 s 的。
没有，这两个是 x y，两个是
为什么？
为什么？
那为什么同样是 r theta phi 的话，这两个它表达式不一样？
什么东西？
就是那你这边不是写说这个是这个零负一是 x y，
对，
那这个不就是这个平面？
不是这么说，OK，这个阿迪达怎么从这里来呢？是我们透过那个 chain variable，就是那个 f 等于 r cos 迪达跟那个 y cos 迪达。所以你透过那一个的话，你把这个阿迪达放进去，你就算到这个 x， 你放进去你就算 OK，那我写。所以我把这个阿迪达放进来这里，我就回来这里，所以它是透过这个转换，所以但是他们还是在同一个 xy 点上面。这个也是这么说，这个
这个
对，
这个的 x 等于什么？这里的 x 等于什么？
这里的 x 跟 y 等于什么，对吧？你给我想一下怎么跟你处理呢？所以意思说我们要选一个点来看哦，对不对？比如说我们选这个点来看看，所以这个点是0、1啊。所以你看0是什么？0是迪达，r 是1，所以你就放这里来看咯。所以这里叫什么？0 cos 0是1，r 1是1，然后 sin 0是0，所以是这边也是这边叫10哦，对吗？你算一下，cos 0是1嘛，r 是1嘛，1乘1是1嘛，y 呢？sin 0嘛，是0乘1都是0，所以是这个，所以这个点叫做0，在 xy 的 coordinate 的时候。虽然我不知道它的那个physical 的意义是什么，但是它叫这个名字。对，比如说这个嘛，比如说这个也很怪嘛。其实如果我不告诉你怎么 理解这个 theta 跟 r， 也很奇怪啊，怎么忽然间有1跟3 power 2？但是我告诉你怎么理解，所以你觉得比较自然。
为什么有 xy 不两个？你明明可以就是这张图里，你同一个点嘛，有2种表示方式。
继续。
那为什么就是要去和它这个2个不同的？你可以
上次因为上次我们在画那个 polar graph curve 的时候，我们觉得有一点难 visualize， 但是变成这一个的时候就比较容易 visualize。这只是一条线嘛，但是那个 polar curve 要转啊、绕啊、什么的。记得我们上次有画那个 polar curve， 记得吗？就是我们从这个 curve 画成类似这样的对，我们 start from 这个 curve 去这个 curve， 对，不然的话你就要一个一个看这边要怎样，这个要怎样，这个怎样的，不然我们就从这边看这个大体的 curve， 然后我们就把这个 curve 来放在这，画在这个xy plane 上，就像这个，这里你看这里这个是一个圈，但是这里是一条线。
这里意思，它这个是等于 x 平方加 y 平方等于1，这个式子在这个表呈现出来。
对。OK。Hello. Testing. 1 2. Okay, good. Yeah. So for this one is really the accent of our drawing our polar curve. Okay, this is really the accent. So you might think I got a straight line. Okay, I got a long straight line. How does this turn into a circle? Right. So I'm identifying some point here. Right. Okay, so because cos the function of cos is periodic, okay, so we identify the 0 and 2 pi together. That's why this straight line get identified to a circle. Does it make sense? Okay. This is actually on how we draw the polar curve as well. Remember that example we gave in class? So we start with this curve, and then we draw the limason, right? The limason, the snail, right? So it get identified as well, the endpoint, right? So the endpoint here get identified. Remember? Can recall? Okay. So why it get identified? Because the cos is periodic. Cos 0 is the same as cos 2 pi. Okay. Yeah, please do more example, tutorial, and then let me know any issue you encounter. All right. Okay, so let's start. So next, we compute the arc length of normal curve, right? Anyone can remember what's the formula? L equals to dx dt, maybe dt, yeah, square plus dy d theta square. Okay, so how you remember this? You remember the Pythagoras theorem. Okay, and then make sure that you use the right variable, and then make sure that you integrate over the right domain. Okay, that's all. And then you remember the Pythagoras theorem. Okay, so now how you change from xy to r and theta? What's the bridge between these two? X equals to r cos theta and y equals to r sin theta. Okay, so this is the bridge between these two. So now you want to go from xy to sin theta, then you just do the differentiation, right? Okay, so that you can express everything in terms of r and theta. So let's do it. So what is dx d theta here? What's ds d theta? Negative r sin theta. That's all. plus plus dr d theta cos theta. Okay, so maybe some of you ask, why not just minus r sine theta here? Okay, really, these are, see from the top here, r is a function of theta. So actually, I'm not correct in writing just r. So this r actually is a function in theta. Okay, so it's two multiplication of two functions in theta. So you need to do product rule. Okay, all right. So this one makes sense or not? Okay, correct. Things correct. Okay. How about dy d theta? Cos theta plus dr d theta sine theta. Okay. So next you just square and then you plug the number in. What do you get? You want to do this? Okay, let's do this. So dx square plus dy d theta square is equal to, yeah, try calculate it up. What do you get? Yeah, see if you can expand this guy, these two guys. So you expand these two, there's some rule you can use, right? Binomial expansion. Theta. And how about dy square? R square cos square theta plus dr d theta square sine square theta. Okay. So you might see that there's a lot of junk term here, but when you see cos square or sine square, right, you should feel happy. Because if you add cos square and sine square together, you get 1. Okay, you will simplify them. So always look for sine square and cos square. Okay, so you can see that they produce exactly the same cross term, one with plus, one with minus, so they cancel out. Okay. And then what else you left with? R square, sine square, R square, cos square. Okay, so you can factorize, get R square. And then similarly, you can factorize dr square, d theta square. You get dr d theta square. So you get r square plus 2r 2 theta square, which is what you want in this formula here. Okay. Yeah. Any issue? Can follow? Can follow? Okay. Okay. Yeah. So maybe I change this to t so that they are potentially different variable, and maybe I change this to cd so that it doesn't clash with the ab on top. Okay. So okay. So far okay. You want to do one example or want to skip? Do one example. Okay. But I don't want to do this example here. I left this example as homework because there's a long integral that you need to do this. But I pick a easier example. This one left. Because even if you do this, it's not very inspiring for this cardio. So let's do one example here. So the example I pick is that r equals to cos theta. Anyone remember how to draw this? How to draw this? Let me see if it is the right example we're talking about. So is the shifted zero, a shifted circle, I mean, sorry. Remember this? Yes, okay. So if I want to compute the arc length of this circle, what do I get? Okay, so let me label the center first. So it's 1, 0, and then radius is 1. So what's the arc length of this circle here? A circle. What's the arc length? Circumference. 2 pi. Okay, so you know that it is 2 pi, right? So what's the domain of theta for this curve using this polar curve here? What's the domain? 0 to 2 pi? I think it's too much. 0 to pi is already enough. Okay, so what is pi? Check what is pi. When theta equals to pi, what happened? R equals to cos pi, which is minus 1. So where is minus 1 pi? Okay, so how to think about this? So you should start from all positives first. So start from 1 pi. Okay, where is 1 pi? 1 pi is here. Right? 1 pi is this direction. Okay, because 0, pi over 2, pi, and then 1. Okay, it's this direction. But minus 1 pi switch to the other direction. Okay, so it's actually when it is theta equal to pi, actually you reach this point already. Okay, so this means it's 0 to pi here. Okay, if you go pi to 2 pi again, then you will loop around again. So you loop twice. Okay, so now I want to just loop once. Yeah, make sense? Make sense, huh? So far, okay? Okay. Okay, so now we try to validate this formula here, although we prove it in general. So let's use this formula here. Okay, so we got this formula here. So in this case, we want to integrate from where to where? This one is 2 times wrapping. This one is 1 time. So we want to integrate from where to where? To compute the full circle, one full circle. What's the integration domain? 0 to pi. Good. So what is r square here? R square is equal to cos square. And then dr d theta square is, okay, so first compute dr d theta first. So what is this? Minus sine theta. Good. So dr, so if you take the square, it's just sine square. Okay, good. So you see, I got cos square, sine square again. Okay, so I got cos square and sine square again. Which we get? What do we get? 1. Good. So square root of 1, you get 1. Am I doing something wrong here? Okay, I'm pretty sure we start with the wrong function. Okay, let's go back and look for that example here. Okay, so we want to start with this function. Okay, so it's 2 cos theta. So the variable 2 here will help you shift this thingy. Okay, so it's 2. Start with 2. So let's start with 2. So start with 2, 2, 2, 2. So sorry, square after square you get 4. After square you get 4. So I get 4, I get 4, and then I get 2. Right? Square root 4 is 2. Okay, so what's this? This is just 2 theta evaluate from 0 to pi, which is 2 pi. Okay. 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 So this one left as homework because the integral is quite tedious. So try and work it out at home. If you still get stuck with the integral, we will discuss the integral. So far, okay? Okay, so before ending this section here, we will talk about conic section. So conic section, we won't go into much details. We just introduce the basic curves, and then some terminology to describe that curve. And then for the next section, we will use this conic section, this curve, to build 3D object. Okay, yeah. So okay, so what's conic section? So let's draw some diagram. Okay, I think mathematics doesn't exist without diagram. Okay, so in this section here, let me write down this. Okay, let's give you some idea first, then I will let you off for rest. So conic section, what's conic section here? So actually we are looking at all those quadratic function. Okay, quadratic function. For example, this x squared. For example, x squared plus y squared equals to 1. Okay, so these are what we have seen before. Circle or parabola. Okay, so this one is a parabola. Parabola. Okay, parabola is something like this. This is a circle. Okay, circle is what we've seen in the first class. So how about what else you can think of it? How to play around with this quadratic function? Okay, so you can also take the scalar, right? You can change the scalar, or you can change the scalar to something like this. Okay, something like this. Okay, so change the ratio here. Okay, so here is over 1, right? But what if you change the ratio here? Okay, then this one will be eclipse. Okay, so this one is circle. Sorry, this should be a circle. And then this one is some eclipse. Okay, so it's like a circle gets squished. Okay, so you can imagine that you can squish y direction, you also can squish in the x direction. Okay, depend on your a and b. Become the what do you call that? Yeah, sun eclipse, moon eclipse. It's ellipse. Okay, actually, yeah, ellipse has something to do with sun and moon, but later we'll talk about it a little bit. Okay, ellipse. Okay, how about changing the coefficient to negative? Okay, if you introduce some negative in, what do you get? Okay, so you get something like hyperbola. Or instead of joining the two curves, it becomes splitting up. Okay, so you maybe you wonder, hey, you say conic section. Where's the con? Where's the con, right? Okay, so where's the con? So let's draw a con first, and then we talk about how these four diagram occur. Okay, let's take some con. Okay. I draw the squish con. Okay, maybe I can draw the squish con. Okay, imagine this is a time con. Okay, so here's a future, here's a past. Okay, so where's the parabola? Where's the parabola here? Yeah, where's the parabola inside this con? Where's the parabola? Okay, so if you slice this way, if you take a slice this way, then you will see the parabola. Okay, makes sense or not? Yeah, you can make a con and then you try to cut it, and then you will see parabola as a cross section here. Okay. How about circle? Circle, you just slice horizontally. Okay. How about squish circle, ellipse? So you slice a bit off tangent, not off tangent, off horizontally. Okay. Ellipse. Hyperbola. Hyperbola is like two parabola, right? So you slice up top and bottom together. Oh, it's like this. Okay, so you take cut through. Make sense? Okay. Let me remove it. You guys still want to keep going first before I take a break, or keep going? Take a break or keep going? Break? Break, Okay, maybe we break for another 10 minutes. 不然听不见。
就是那个定义是比较快。
你说这个
对
？OK，
那个是看出来
怎么看出来哈？其实你要试的，就是这个点。你如果看我们这个 example 的话，我们是试出来的。
对吧？
如果你不试的话，
考试的时候就是
你大概咯几个重要的点你要检查，就是零啊、派啊、不派啊。OK，还有一个想法是这样，就是从那个 graph 开始看。应该要告诉你们的先。所以还有一个看法是这么放呀，所以还有一个看法是这样。如果你 plot 这个 r over t theta，这个的 curve 是 r cos theta 嘛，r 只是把那个拉长，所以你还是一样的 cos theta 这边，对不对 ？OK，所以你看，你从这边开始 graph，你看0到 pi over 2的时候，不是它从0到2，讲错吗？没有讲错。OK，然后拍到拍2到拍是，
没有上一题它是那个，
对，难怪我就觉得它不太对那个说的。OK，对，难怪我就觉得它不太对。OK，你看啊，它是从1开始嘛，1到拍over 2是1到0，所以你看它其实是从这里已经连到这里了哦。确实啊。OK，为什么？因为它经过了一个 e，其实，因为它是2嘛，它经过一个 e 是这里，
二是负1的时候，相当于就是把它反消是吗？
呀，对，所以它其实用这一段已经把这个已经画好了。OK，等一下，我会跟全班人讲。分级，呀，对，你比较容易是从这个课开始想啊，就是那个 r theta plane 开始想。因为我们最熟悉的就是那个 plot r again，就是 plot x again y 嘛，这个是我们最熟悉。
那你比如说前面那个坐标的话，
哪一个坐标？
它的坐标就第一个，它那个坐标是负数嘛，后面是角度的话，就是也是一种起坐标表示方式。
这个，你的这个表示
就是它也是一种起坐标的表示方式，是吧？
是，对啊，对。
然后我想问一下那个。
说什么？
没有人。
OK，
一样的吗？
对吗？
大家还是你的笔
啊，后边的吗？
逗老师。
有一题你讲上面那个要找 vertical tangent 的那个，那就它 approach infinity，
对，
那个一定要做出来吗？一定要做那个来 prove 啊？还是我可以
不然你
做？
不知道它发生什么事。
我不会拿那个 dx， dx per dt， dx per dt 等于0吗？
你是它被零除
啊？就因为我们上面的是 dx per dt 跟 dy per dt 是等于0，我们来找 horizontal 跟 vertical，我可以直接用那个。
但是它两个都是零，你怎样决定它是 horizontal 还是
对吗？一
vertical？
个是 dy per dt 嘛，一个是 dx per dt 嘛，dx per dt 是 vertical 嘛。
对
啊，
但是它也符合 dx dy 等于 dt 啊，没，它也符合 dy dt 等于零，它两个都符合。所以你是要画横呢，还是要画直呢？
不是，
哎，
不是 dy per
对
dt
对
是 horizontal 吗？就分别不是？
对，它两个都是，它两个都有，这个才是问题。它是两个都出现，这样我要画横还是画直？
快一点，
什么？
快一点，
那一点？
你讲了吗？如果是
对对对，I mean，没有，我已经那个了，我已经 correct 了。一个点是两个是符合的，但是符合的话不一定代表它是一零点。对对对，所以你就要看它附近发生什么事情。
比如说那个 left hand limit 跟 right hand limit，
就是他这种，
而且我
他说，
做
比如说前面是正数，就是考试的时候，比如说，
我以为
就是
写一个
比如
零就可以
说它定用就是用后面的角度用4，或者比如说就4分之3的话，如果我用比如说，我想一下4分之7派是不是也是一样？
讲不，这个例子
就同个坐标对，就是7/4派跟负3/4派是不是都可以分？比如考试
是5/4派耶，
对啊，
啊
不是，
它这里写5/5派。
它的角度，你看把这个路考想做，就是都可以的是吧？
可以，
那就是你自己说，就是有什么规定，然后你这个学期
要什么？
就是好像讲这个时候，
对，
讲的是对吧？
哦对对对，后来没有了，没有规定，换成这个了，我都
哦，
对对对，
都可以是吧？
都可以。其实就是这张图啦，其实是这张图，其实感觉这张图又不 OK，这个不完整，我跟你说呀，这个图，呀，这个图，
老师，我想就是比如说你让我们做就是作业的话，
这个讲一定要 pro 还
就是
是
再放在哪
这个
里？
一边一样？
我放在
等
这里，我会放在这里的前面这样附近。
第一章的话，就是
这里，
对，好，那我
你怎样？
就是这个教材是相当于
是这个啊，你问呢？
那就是说它这个题目，它题目
怎样？
就是你不要自己找，就是目录里面这个。
对呀，
我自己好像没找到。
为什么？哦，它是不是不能点啊？我这样发现。
哦，没有，我好像传到另外一个可以点。
如果给你电话，
它点不到是吗？
如果等于零的话是
为什么？
你看我这里看看。
哎，
我想请个假，
你请个假。
对，够了，
哦，你发啥？可以，你发邮件给我。
明天发上，
什么？
是明天发上，今天的假。
今天呢？他现在要走哎。
几岁？
就是他这个
那个顶这一堂课，他说这一堂课会发烧，应该没有来。
点不到这个，你要去找6
就是对了，他这个是
10点多，10点1。
就是他这个教材的话，就是例子跟练习题都是一起的，
对，
都一起。
它是在10点1的后面。
10点1的后面。
对，
就是他10点1是先把例题全部讲完，你这样子跑太慢了。
OK，
我看一下。
没有，你只要去 section 1，
你这样，OK，
你只要去 section 1看就可以了。它全部是一样的那个形式的。你看，给你看，
就是
你看，看过这是 review，你看， 对 concept 的你看1.1啊，
对
它是做过后，然后它就会有粒子在最尾端这边呢，它就 exercise 哦，exercise 结束就新的，所以你就去10.1的找它的，
10.1找 OK，
对，
那
那 H 肯定
那就是就是
对，
这个里面这种教材里面是不是
也有类似的，
也有练习
也有练习题，然后这一个我已经答案放上来了，Adam 我答案已经放上来了，
爱做
对吗？
是
好，对。
那我这个算 negative 吧？因为你那个 lesson set 嘛，不是自己上来的，是有个 negative。对，我不你这个讲是呢，
我也不知道那个是之前的，
我不比较上去。
对，
结束了
我看，下啊，有好多个哪个地方，你看这边有哪个地方，有一个哪个地方。
这个是一
不然我看一下你的对还是不对，然后再看一下我的对还是不对，然后再看一下对还是不对。OK，你先给我你的，你做了你先给我，然后这样子，你要现在解决啊，还是
就这个问题吧。
OK？这个问题不是它一定是一边是 infinity，一边是哪个 infinity，只是我要知道只是要知道哪一边吧。
它应该是
我觉得
这里
你有，
是
对，
那个的比例，是这里又有一个那个的，它乘进去了对。
然后你是说这个是算错的？
可是我算的这个是一有，
可以，你等下给我看一下，然后我再仔细看一下。
够力啊！
但是问题是啊，它肯定是一边是 infinity，一边是哪个 infinity 啊？其中一边是那个。OK，
它这练习答案是在哪里？
最尾端，
最尾
端，它只有答案，它没有步骤就答案嘛。
我就答案没事，对，我就对一个答案就行。
OK，
那个就是之前就是你上次作业有道题，它就是判断那个那个曲线就是平行跟垂直的那个，就是我对它那个导数之后练它分子或零或者分尾，然后算它的答案，就是能不能用画图来说明，就是因为有种情况好，那分子分母都会左极限右极限，就是
哦，就是刚才那个啊，对，
就如果你能通过图像的话，是能在图上点找到的话，
因为其实它一开始哦，它怎么说呢？
因为就是好像是
图像只能够是一个 sketch 吧。
sketch，
那你还是最好是把它说
左极限右极限，把那个点求出来，然后再然后就趋近于那个点。
对。
那比如说你自己有没有有查？那个这个是求的是是 dt 还是 dydt 还是
dydx
dy 是 dydx dydx？那你之前是没有乘开还是就乘开相当于你就是直接是两个相乘的时候，
对，反的咯，我把它反了，你要除了把它反过来。
这样
OK，
那你是二分之二这样。
And where's the front？
那你就是dydx 左边右边都可以，正负正乘负乘，那就
里面算一个是 positive 的那个对吧？
算错了。
你算出来 ，OK， 这样对。OK，
就是你这种情况是就是分母为零的时候检验分子为零有
不是，因为它是 both 两个都是零，所以
两个都是零。你就把它写出来，然后检验两个都是零。
因为你不知道要，对，你就要算 dydx。
谢谢老师。
OK， where do we stop？ OK， I understand that there's an issue when you find, hey, where's Hong Yuan? Huh? You don't know? Okay. I thought you guys know it together. But somehow she get lost. Okay, anyway. Okay, I know that for this kind of question, right, you want to determine a domain is probably very hard for you to determine the domain, right? Okay. Yes, okay, good. So let me list this guy up. Okay. How to determine this domain? So the most familiar graph to us, right, is the SY graph or the R theta plane graph, or yeah, or the how to say? Yeah, so this kind of graph is more familiar to us. I mean, at least for me, not sure you. Okay, right? Does it make sense? So this is the R theta plane. This is the XY plane. Okay, remember the example we talked about just now. We have the R theta constant line, but when we put into XY plane, the line wrap become a circle. Okay, so it wrap infinitely many times. So you want to wrap just one time. How to determine from where to where? Okay, from where to where? Right. So what? So first you plot out the R theta plane graph first. Okay. Okay. So R equals to 2 cos theta. Right. So cos theta is this basic curve here. Okay, you can keep going on. Okay, okay, to be consistent, I just keep going on first. Okay, so how to make up this full circle here? Okay, right. So you can start from one point. Okay, the point I prefer is at the angle 0. Okay, start with angle 0 here. So when it is 0, the radius is 2. Okay, so when it is 0, the radius is 2. Right? Okay, so you follow this curve here, 2 and then go to 1 and then go to 0. Okay, so 2 and then go to 1 and then go to 0. Okay, so you finish a semicircle just with this 0 to pi over 2 curve here. Make sense? Okay, and then from pi over 2, you start growing up to 1, but it's negative. Right? Okay, so negative up to pi. And negative up to pi. Right? So what to do? Then you also just keep going up to pi. Okay. So what is minus 1 pi? Just now we discussed about this point here, right? Minus 1 pi. So minus 1 pi is just equal to what? Equal to what? Minus 1 pi equal to what? Hey, sorry, this is 2, right? Sorry, this is minus 2. Minus 2 pi. Okay. So minus 2 pi will jump to here. Right. So I want to put here. So here is 2, 0. Okay. Is also equal to minus 2 pi. Okay. Make sense? Because 2 pi 2 is here. Wait. Yeah. I mean here. Okay. So minus 2 pi become here. Make sense or not? Okay. Let me draw. Here is 2 pi. Okay. So you do minus 2 pi become that side. So far, okay? Okay. So yeah. So I suggest you to start with this curve, this kind of graph first. Graph R against theta first, and then see how this radius changes. You plot it on the XY plane. So whenever we talk about polar curve, usually we mean the curve drawn on XY plane, just using r theta coordinate. Okay. 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 If there's an issue again, you go and do exercise, and then we discuss exercise again. Do until you know the concept. Okay. But we cannot spend too much time doing here. Okay. But you do at your own, and then you still cannot see it, and then bring it out again. Then we will discuss again until the concept sink in. Okay. So okay, just now we stop here. So we have a conic section. Describe various quadratic function. Okay, various form here. So this is the classification of this quadratic function here. Okay, so maybe you would say, how about a function like y equals to s squared plus x? Okay, how about this? Okay, so how about this? This lie in which category? Okay, maybe I put 2x. Maybe I put 2x. I put 2x. Okay. Right. So this is just a shift, right? So you can do completing the square. Okay. So this is just a shifted. I think it's a shifted parabola, right? Okay. So you can just I remember this is a question asked by my foundation cousin. So they asked them to do this assignment, shift the parabola, shift the circle, or shift the ellipse. Okay. So if I do this change of variable here, not change of variable, just completing the square, I'll get x plus 1 squared, y plus 1. Okay. So it's go back to this form here. Okay. So y equals to something square. Okay. Be shifted in y direction as well. Yeah. Okay. Make sense or not? Yeah, makes sense. Okay, so you cannot go between these curves, but within themselves, you can go between. Okay. Yeah. Yeah, you can go back and try, but okay, next. Next is another definition of this conic section here. Okay, so first we fix a line, okay, which we call a directrix. Directrix. Okay. So and then we fix a line. Okay. And we fix a point called the focus. Okay. So this is very much like the lens. If you have learned physics before, the convex and the concave lens. Okay. So look at this focus here. So we can measure. So we measure the distance from the focus point to the point on our parabola, ellipse, or the hyperbola. Okay. And then this will have a ratio between the distance from the point on the curve to the directrix. Okay. So let P be a point on the plane, okay, not the plane in the curve, okay. So PL is the length, the distance between P and this line, okay. And then let PF be the distance from the focus point to the point on our curve, okay. So the ratio, if we take PF, okay, so let me write down. So if we take PF to the focal point, divide by the distance to directrix, then it forms a ratio. So this ratio is always constant, okay? So the matter is, what does this ratio equals to? Okay. If it is between 1 and 0, then the point will form a ellipse. Okay. If the ratio is 1. That means it's equal distance. Okay, equal distance from focus, also equal distance from the directrix, the fixed line. Then it is a parabola. Okay, so you will form this infinitely extending parabola. If the distance to the focus is greater than the distance to the fixed line directrix, then it is a hyperbola. Okay, yeah, that's all. In a moment, we will see that we will use this to build the curve in terms of polar coordination. Okay, coordinate. Okay, so for example, you see, if E is in between 0 and 1, you have an ellipse. If E equals to 1, it's equal. So there's one case here, so you get a hyperbola. And sorry, parabola. And then if E is greater than 1, then you get a hyperbola. Okay, so that's all. Nothing special yet. So now you can see that we have different parabola. This is what we call open up. It's open up or open down or open right and open left. Okay. So depends on what? Depends on what is the coefficient and depend on where you put the square. Okay. Depend on where you put the square, depend where you put the coefficient. So why A cannot be 0? What happens if A equals to 0? Yeah. Y equals 0 in the first case. X equals 0 in the second case. So you just get a straight line. Okay. So when A start increasing, this straight line start folding up, or folding to the left, or folding to the right, or folding down. Okay. So this is the parameter. Right? I think this is pretty important, right? When you want to model something. So if you change the parameter, then the line will get fold up or fold down. Note that this one is not linear transformation. This is x squared, so it's not linear. So okay, anyway. Yeah. So just start fold up, fold down, and then so the standard equation for parabola is this: y squared equals to 4px. We won't derive how this come from. If you are interested, you can look at the textbook. But what we want to know is from this equation here, how to get directrix, how to get focus. Okay. So if you write it in this form, this P here, P0 will form the focus, and then x equal to minus P is the directrix you want. Directrix. Sorry, it's directrix and not directrix. Directrix. Okay. And then there's another point we call vertex here. Okay, so vertex, what's this point here? This is the point between focus and the directrix with the axis. Okay, so this is vertex will appear in the middle of focus and the directrix. Okay, along the axis. Okay, that's all. For detail, you can see it in details. We won't do this exercise equation also. You can do it. You can try it at home. Okay. For now, we just want to learn the basic picture. So for ellipse is, you remember, ellipse is a circle with a different ratio. Okay, different constant. Okay. So you divide by a square, divide by b square on both x square and y square respectively. Okay. So there's some terminology here. So what does this AB doing? Okay, this AB is actually this intersection here. Okay. Okay. So this AB will describe where you intersect the, this is for the minor axis, and then the major axis. So if you change direction, your major and the minor will change as well. Okay. All right. So, okay. So, what else? Okay. So how you compute the eccentric from this piece of information here? Okay. So the eccentric here is computed by taking C over A. So what's A, what's C? Okay. So A here also tells you the length between the focal point to this what do you call this? It's not vertex, but also it is it's the B point here. Okay. And then okay, so if you extend this A, right? Okay, if you extend this A, you can see that this ellipse here gets squished. Can I say get squished? Feel like squish on x-axis. So this part, if you extend this A, right? So this will get longer, this ellipse. Okay. If you extend along C, right? Okay. If you extend along C, then this ellipse will like grow longer sideways. Okay. So it is the ratio between these two lines tells you what's the eccentricity. Okay. So how to get C? Luckily we have a right angle triangle here, so we can compute C using B and A, which is B and A. We know from the equation here. Okay. So far, okay. Okay. We don't tell you how you derive. If you are interested, you can go and look for the book. Okay. And then hyperbola. So the main differentiation between parabola and hyperbola is where you put the negative sign. Okay. If there's one negative appearing, then it is hyperbola. Okay. So it's like the negative will cut. Is it cut? Let me see. Okay, never mind. Yeah, cut. Cut that eclipse, then become two parabola. So also from A and B, you can obtain your eccentric. Okay. So where's the triangle? Triangle is here. Okay. So where's the A and B? So we need to look for it. And then you have an asymptote. Okay. You also can obtain from B and A. Yeah. Yeah. So far is this. So you need to know how to find this focal here, focal point. Okay. Let me write down what you need to know. So you need to know how to find focal point, and then how to find directrix, and then how to find what? Asymptote. Okay, so this word is what you need to learn. Okay, so I won't tell you how to find directrix in this case. So how to find directrix? So the formula is so these are two possible directrix you can use. Directrices. Okay. So x is equal to plus minus a over e. Okay. If you are interested with the derivation, you can look for the books. For now, you just need to know how to find it. Asymptote is asymptote is this. This one is asymptote. Okay, let me label it. So these two are asymptote. So one and this one are asymptote. Okay, and then focal point use C to find. Okay, that's good. So this one this is focus. This is focus. I forgot the implication for focus point. Physics has implication, right? If you are at the focus point, you can see something or you can't see something. I forgot already. Anyone remember? I forgot already. There's a physics interpretation for this one. Is they need to design the concave or convex lens, right? Like you are long-sighted or short-sighted, and then they need to make sure the focus line. Yeah. Okay. Actually, I haven't tell you what's the directrix here. So the directrix here is also A over epsilon. A over E, sorry, not epsilon. Okay, so directrix. Directrix is the one that characterize all the point. So directrix is the okay. Let me show you another theorem first. Directrix is the point that tell you the ratio between the point on your curve and distance to your focal point. Okay. Yeah. So these are the terms you need to know. Given you equation, how to find focus, how to find directrix, how to find asymptote. But it's really straightforward. You just use the formula. No need much derivation needed. Okay, so these 2 points is another possible definition for your ellipse and hyperbola. So if you have a point on ellipse, okay, there's 2 focal points you have. Okay, so you can take ellipse and then calculate the distance between the 2 focal points and then add them up. Actually, it's 2 times A. Okay, A is the thing appear that below your x square. Right. Okay, so which means what? Which means the sum of the point, sum of distance of point to the 2 focal points is constant. Okay. If you are on hyperbola, if you take difference of the distance of that point to the 2 focal point, it is also a constant. Okay. One is sum of sum, yeah, sum of two distance is a constant. One is difference of 2 distance is a constant. Okay. Don't remember, when you add up is the same, so the ellipse join together, the curve join together. If their difference is constant, then the ellipse break become hyperbola. Okay, so yeah, so you need to create some imagination for you to remember. Okay, don't just plainly remember sum is that one minus that one. So you create some scenario for you to remember. Okay. Yeah. Okay, then you can try and do this exercise. But so this shifted conics is what we discussed just now. So you just try it. Okay, this part more interesting a bit. So conic section in polar coordinates. Okay, so you can see that we have four types of conic section, right? Okay, but if we describe as polar coordinate, we just need two formula to talk about every conic section. Okay, so how can we do that? So we just use eccentric, the information of eccentric, and D. What is D? D is the directrix. Okay, so these 2 pieces of information is enough to build ellipse, hyperbola, parabola, circle, everything. Okay, I don't think there's circle here. So ellipse, parabola, and hyperbola. Okay, so these 2 pieces of information, we can build 3 graph. Okay. Yeah. Okay. So we don't care about derivation. You just need to know how to use this use information for this one is enough. Okay. So the key point here I want to point out is you need to make sure here is a +1. Okay. So for example, there's some question. Yeah. So you need to make sure here is a +1. So for example, right? So for example, let me just write something up. 4 + 2 and maybe 2 cos theta. Okay. So this is still not in this general form yet, right? So you need to make sure here is a +1 first. So you need to divide everything by 2. Okay. Only from here you can find what is E. Okay. E is coming from the coefficient of cos sin theta. And then after you found E, then you can find D. Make sense? Yeah. Okay. No need to know about derivation, just need to know how to get this information out. Okay. Depend on cos or theta you use, right? So your directrix will lie differently. Okay. So if it is a plus cos, okay, your directrix will be lying on the right. Yeah, right hand side. If you have a minus cos theta, your directrix is lying at the left hand side. If it is sine, then it will be on the y direction. One is at the top, one is at the bottom. Okay. So these four picture here summarize where you can find your directrix. Okay. Although you can see that this is just one parabola, right? So depend on E. So if E is what? If E is less than 1, it is a ellipse. So let me draw something. So if E is less than 1, you can complete this graph to an ellipse. Okay. If E is equals to 1, then it is a parabola. Okay. If what? If E is greater than 1, it is a hyperbola. So you add another guy here. Okay. So you don't think that this is just an hyperbola. So you can complete that graph. Depend on your E. Yeah. Okay. So depend on your E, you can complete those graphs. Okay. So far, okay. Still straightforward. Yeah. If you try to work some examples, see if you can find. You see, this question are just finding eccentric, finding which cone you have, meaning what E you have, and then find the directrix. Yeah, and so on. So yeah, given a function in polar form, in a polar form, or the XY form, Cartesian form, can you find this important point? Focus, eccentric, directrix. Yeah, but they are should be straightforward from the formula. Okay, just no derivation needed. Just apply formula. Okay, so yeah, so just now we talked about eclipse, right? So at first they designed this is to study this motion of the planets. Okay, so how planets move. So planets so if you imagine there's a sun, okay, maybe we take this. So you got a sun here, okay, a big sun. Okay, so there's a gravity here. So gravity will pull other planets together. Okay, so at first they thought they move in a circular orbit. Actually, it turns out it is not. So it moved in an ellipse form. Okay, because why? Because this is not just two gravity affecting each other. There's a third gravity affecting each other. Okay, so this is called a third body problem, three body problem. You guys know what's three body? Yes, yes. So that name is coming from this three body problem. So that story talk about extraterrestrial creatures, right? There's someone want to come in, right? So it's like there's another third planet that governing this how do you call it? The planetary motion. Okay. Yeah. Okay. Oh, actually, right. If you see the video of this orbiting the planet orbiting, right? It's not just 2D. It's not on 2D. It's actually 3D. Okay. So it's actually the sun is moving forward. Sun is moving as well, and then the other is also moving like this. Okay. So it's like everything is like going forward. So you are like turning and then everything move forward. Can you imagine or not? Yes. Okay. Yeah. If not, you can go and find that picture, the video. All right. What time we finish our class? 11. Okay. Okay. Still got time. Okay. I think we go pretty fast for this conic session. If you go back and try the answer, you get stuck and then we will revise again. Okay. Otherwise, I think it's quite pretty straightforward. You just apply the formula. There's no derivation. Okay. Is it okay? Yeah. Okay. Okay, then we will continue to next topic. We will try go as fast as possible, and then we will slow down if needed. Otherwise, we scared cannot finish. It get tedious after when we go the further subject further topics. But for now, what do we do for now? Let me find. Okay, keep going. Keep going. Yeah, keep going. So, only just half an hour. Okay. Yeah, we will take a break after half an hour. Okay. So next we start a new chapter, vectors and geometry of space. I looked through your lecture notes, right? I think we just focus on 3D, 2D for now. Okay. The most dimension is 3D. Okay. So just now what we do is 2D. I mean, in chapter 10, we have 2D. We have 2D plane, SY plane, and then we describe as a polar coordinate. Okay, now we go one dimensional higher, 3D. Okay, so it's like the planetary motion. We stare in eclipse. Now the everything, sun and moon and earth move forward as well. So we have 3D now. Okay. Just to mind you, we are like doing revision on linear algebra for the first section here. Okay. So try to recall what you learned from linear algebra. So in 3D space, we have X, Y, Z here. Okay, we have X, Y, Z here. Three direction. Okay, three direction. Okay, by the way, do you know what dimension we live in now? The latest. No, 4-dimension. Okay. So the 4th dimension is the time. Okay. Okay, let me ask you another question. Where can you find 4D in 2D? 4D in 2D. Yeah. No. It's pretty. I mean, daily activities. 4D in 2D. 4D in 2D. Okay, let's have some talk before we go into serious. Huh? Any idea? No idea. Then when you're watching TikTok, YouTube, it's 3D and then you're controlling the time. Yeah. Okay. So they think of 4D like a movie slash. Okay, it's a movie slash. So the whole how to say, the whole universe block. Okay. So you are like moving like a movie every day. Okay. There's a universe block. Yeah. Yeah. Okay. Maybe there's next time we will share more on these things, but okay. We'll keep continue first. So in 3D space, we have X, Y, Z. So you can go forward, you can go to the right or left, and you can go upward. Okay. By stairs, I mean. Okay. And then the next is this right hand rule. Okay, so what's right hand rule about? This is actually the orientation. Okay. So we always draw like this, right? Okay, why not we draw something like this? Or something like this. Okay, so why? No reason. This is just a convention. Okay, so usually we start from a real line. So here is a negative infinity and infinity. So we're going from left to right. And then for y, we're going from bottom to up. Okay, so this is just a convention. And then this convention somehow can be summarized using this right hand rule. So if you go from x to y, then the z will be by definition going up from the screen. So if you're going up from the plane, okay, if you imagine x and y, and then you do right hand grid rule, z will be coming out. Okay, so this is how we determine z. Okay, yeah, this is just some convention here. Yeah, so x, y, then z will be coming out. Okay. Okay, this is convention. So please don't draw something like this. Okay. So next. Okay. So these are the coordinate planes. So you can see that in 3D you can find some 2D, right? So if you fix your x, okay, if you fix your x, there's a YZ plane here. Okay, if you fix x, if you fix y, you get XZ plane. If you fix z, you get XY plane. Okay, so these three plane here divide our space into 8 parts. Okay, so divide our space into 8 parts. 1, 2, 3, 4, and the bottom 5, 6, 7, 8. Okay, divide into 8 parts, which we call octane. Octane. Oct is 8. Odd is 8, but October is 10. Is it weird? Yeah, Octopus is 8, but October is 10. There's some history here. Okay. Yeah, there's some folk knowledge here. Okay, and then for a point you can write out the coordinate of the point using this xy z xyz coordinate. So if you have a YA here, and you got a B here, and you got the C here, B here. Okay. And then you can project this point to the XY plane, YZ point, YZ plane, and the XZ plane. Okay. Okay. Yeah. Nothing special here. So this is a rectangular coordinate system. So last time we start with R2, right? So with R2 we have XY and XY. Okay. So we just add another dimension. Right. So we have a plane here. State the equation in R3 that represent the surface given below. Okay. So can you see what's in common for all the point on this plane here? What's in common? Z equal. So Z equal to what? To what? What is the constant? Okay. So in 2D, x equals to 3 slash out one line, right? Okay. In 3D, z equal to 3 slash out a plane. Okay, a surface or a plane. Okay. So you can see that. How to see this? So 2D, you throw away one dimension, you're left with one dimension. Okay. In 3D, you throw away one, you fix one coordinate, you still have two free variable. So you slash out plane. Right. Right. When you use variable, you are starting going back to linear algebra already. Okay. Okay, next, how about the vertical slice? What's the thing in common here? Y. Y equals to 5. Okay. So you need to slash out a plane, so you just control one variable. Okay. So far still okay. How about this? This is what? A cylinder. Okay, so what's the suggestion? S squared plus Y squared equals to 1. Okay. But this one actually they start from the XY plane. So it is a Z greater than or equal to 0. Okay. So S squared plus Y squared equals to 1. You just have a circle, but there's no condition. The condition on Z is greater than or equal to 0. So you take all the circle, you stack together. Okay. Yeah. It's important that you can imagine this. Later we will build something interesting. So far, okay. Okay. Okay, next. This one. Yeah, this one. How about this? This is a plane. What this plane is? X equals to 1. Okay. So this one also is a finite. They also start from, okay, actually it's x greater than equals 0 and then z greater than equals 0. So they don't take this part here. Okay, they don't take this part. And then they start with z greater than equals 0, going up here. Okay. Anything need to add? Okay, so one thing I want to add is if it is x equal to y, right? So the graph should be like just like this, right? Remember? Okay, let me draw it clearer. Right, y to the x. Okay, so if you don't control your z, so you just keep stacking out this line here. So you stack until you get. Okay. Yeah. Okay. So far still okay. Okay. So next is distance formula in 3 dimension. So you can see that this is a soup-out version for Pythagoras theorem in R2. So you need to consider the third coordinate here. Okay, a square plus b square plus c square equals to d square. Okay, so you just keep doing it. In fact, you can do it for n times, n dimensional. You can do this. Okay. I think we don't want to derive this, is it? Don't want to derive. Don't want. Okay. All right. So want to compute this or not? No need, huh? Okay, no need. So do as a homework and then check answer. Because this is just adding one extra dimension. Okay. Okay. Next, sphere. Okay, just now we just talked about circle, right? Okay, now we talk about sphere. Okay, sphere is interesting. So sphere here, we also add another extra condition, extra coordinate here. Okay. So circle, what do we have? Remember, x minus a squared plus y minus b squared equals to r squared. So this is a circle. Okay. So we add another dimension, we become a sphere. So every point that is same distance from the center. Okay. Sphere. Similarly, you can imagine this definition can extend to n-dimensional sphere. Okay. So you have n dimension, n coordinate square. Right? So how about this one? You want to practice change 那个 what do you call it? You want to practice the change of not change, completing the square, or you can do it. Yeah, you need to completing the square for this one. Can do. Okay, let's try do this. Let's try do this. This is a bit similar technique you need for conic section also. Okay, so try to find center and radius of this sphere here. Yeah, try for, okay, after this, then we will take a break. Okay, finish this, we take a break. Give you 3 minutes. Okay, anyone have tried? What does this the last 9? Okay, so it's 3 square. Okay, so it's a sphere centered at 5, 4, 6. 5, 4, 6. Center is 5, 4, 6. And then radius is 3. Good. Okay. Do we do this? How about this? State the. Okay, well, last before we take a break. So state the inequality in R3 that represent the region. So this region here is somewhere in between here. Okay, in case you love. Okay, everything feel this is like a apricot. So what's this? Any idea? Like an apricot. How to tackle this question here? How to tackle? Use slices to talk to imagine. Yeah. Now you know sphere, right? Okay. You know sphere. Okay. So you got 2 big and a small sphere, and then you fill the outside part. So how do you fill? You make more sphere, right? You make more sphere, right? So you make more sphere. So you make more sphere outside, okay, to fill in the part, and then you cut it horizontally, right? You cut, remove the top hemisphere, okay, then you will get this thing here. Okay, make sense? So how to write out? How to write out? Okay, so you got, so inside outside you got sphere. So let us write the sphere equation out. Okay, 4, huh? Right, 2 square 4. Okay, so we have these 2 sphere here. So we want every sphere between 1 and 4. Correct? Correct. We want every sphere between 1 and 4. Right? We want to fill the space here. Right? We want to fill the space. Okay, so we take everything in between 1 and 4. So that means we need to take every sphere that is in between 4 and 1. And everyone follow this or not? Does everyone follow? Yes, I saw someone confused. Please ask if you're confused. Okay, so we take sphere at radius 1. Okay, we sum up to sphere with radius 4. Okay, 4 and 1. Okay, after we fill it, we want to remove the top hemisphere. How to remove the top hemisphere? Good. Let's say equal to 0. So we just care about z, that is less than or equal to 0. Okay, so this equation is what we described just now. Okay, so you can describe everything in word in equation. That's the point of AI. Okay, so you tell AI to do this. So this is what we give equation, and then they do the they do the then I keep forgetting the English word. They do the instruction. Okay. Okay, make sense? Okay, let's take a break until 10:10. Then we come back. 10:10. Đây, đây rồi. Đây.
我说你住蜜月呢？你多久没有回去哦？
过年回去啊？
过年回去啊
你到底哪里人？
我住蜜月，不是蜜月，
哦，因为你一直问米粒，好像你很懂。
跟你不一样啊。
哦，是啊，哪里？梅里哪里？啊，I mean 哪一区 ？Riam 哈，罗，你在哪里读中学？哦，联中。
我是那
OK，我看到你的脸很熟，这样。
哦，
嗯，
你很小我
没有没有没有没有没有没有，
这个像领导啊，年轻啊。
联中。
the perception question is that for design graphics, that then coordinate or detail coordinates.
No. I mean, okay. My idea for Cartesian coordinate and polar coordinate is Cartesian is the rectangular coordinate. Yeah. So in the r theta plane, okay, r theta I think will become the rectangular coordinate, right? Because when you plot the polar curve, it becomes straight instead of circle.
Yes.
Oh, let me think. I think it's not right to say that. Okay. Okay. Let me see. Very good. So if it's r theta, is it Cartesian or polar? Okay. 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 So, Cartesian we know that from the xy plane is the rectangular coordinate, and then polar coordinate is on the xy plane. You can describe circle as a function in polar polar form, but in the r theta plane, we don't really so you're asking what's the Cartesian coordinate in r theta plane?
Oh, actually,
Uh,
from my perspective, I think
Yeah,
that
try.
r theta, the sine curve of
Mhm.
r theta plane is polar coordinate. But since we've learned in the senior high school that the y-axis and cosine
Yeah.
curve is, we call that Cartesian coordinate doesn't Cartesian coordinates doesn't it? I don't know. Like,
Wait, so this is a curve drawn in r theta plane, right? Or sy?
this is a curve, just the sine curve.
Cosine, I mean, what's the so okay, now okay, first fix your plane first. This plane is a r theta plane or yx plane?
So this is my question. So if this is
Mm.
r theta plane,
Oh, okay. So you mean the same curve in different plane?
yeah.
Okay, good. So in this case here, but you see, it's actually the same equation. So in a yx plane, you describe this curve as y equals to sine x. In r theta plane, you describe this curve as r equals to sine theta. It's the same. I mean for Cartesian. But in polar, then you need to do something else. Yeah.
the curve,
Yes.
the cosine doesn't.
Change. So okay. So come back to this question. Back to this.
Wow.
Wait, come back to this one. Okay, where's the flow diagram here?
Yeah.
Okay. So okay. I mean, yeah. So actually, right, actually, so it's better you go from this diagram to this diagram here. Okay, when we talk about polar coordinate, is
natural to think about this
Mm.
here. Okay, these two actually is the same diagram, right? Actually the same diagram, just different description.
Yeah.
Okay, but if I plot this polar coordinate in terms of the polar variable, then this graph change.
Oh.
Okay.
Okay.
Here, same description, same diagram because I draw on the same plane. But if I draw on the plane that describe this coordinate, this graph change. Okay. Yeah. This is what.
它其实就是
啊
坐标系和坐标之间的区别。一个是放在，因为你都是放平面的坐标系，然后你坐标不一样而已。一个坐标是用 x y 表示的，然后另一个坐标是用角做的那个，就是极坐标。
So
Not just coordinate, it's also something to do with the plane. 坐标系。
yeah. Just the variable's name has changed.
一个是坐标系，一个是什么？
一个是坐标系，
坐标
一个是
OK，坐标
哦
那种。
对，坐标就是 x y 嘛，
啊
那个
，coordinate 很
地大。
，plane 很重要，坐标系也很重要。
so
如果你的坐标系是放在它自己的坐标里面的话，它就变了。
你放在别的坐
so it just the variable is different, has changed. The name has changed. So
不止 name 哦，就是它的
之间也有关系的
啊，它有关系，
都是有关系的。x y 和 r 你当然是之间有关系的。
yeah, I know.
这里你看啊，你看再给你看一个东西，现在几点了 ？OK， 还有什么？你看这个东西啊，你看这个 θ 啊，是从 negative infinity 到 infinity。在这个图上面 negative infinity 到 infinity 怎么看呢？它就一直重复啊。但这个呢，我们把它摊开来看，可以吗？
OK.
耶，
我懂了，没事，你先问吧，我还有其他问题。
没问题，
没问题。
来看那个
OK, I have another question. OK, I have
来
another two question.
不是我是来抱怨的。
哦，OK。
抱怨
这太难算了，
哪个？
我算了很多遍，当初是这个女我，
你算得出吗？
我算出来是这样子，我还没有把那个 sin 给算出来。
啊，你算完了？
啊，试算我只把它积出来了，但是那个不定积分我就积到这里，但是那个
然后
就是你不是要换吗？
为什么你 square 你可以直接？为什么你？哦，因为你白派2次啊。
因为它有平方，它有偶次，它有偶次有奇次嘛。有偶次的话，你只能一直用那个对角；奇次的话，你可以用那个。
你这个完整啊，你完整你发给我看一下。如果完整，你发给我看看。
啊，这是完整，但是我没
你发给我看。
但是我只积到这里，但是我没有把那个sin θ换回这个 W，就是我没有把它换回去。就是我是
不用啊，不用啊，不用换回去啊。
啊，我知道
你反正最后要算出来嘛就可以了嘛，不用换回去啊。为什么不用换回去啊？不需要换回去啊，不需要换回去。算 integral 的时候不需要。
我知道。
呀，算 integral 不需要。你发给我，如果完整啊，你发给我看一下。
应该是完整的，但是你检查一下吧，可能
可以，我看一下，你发给我看一下。
一个是这对，就是我不确定啊，这个是老师你想要的那个 x over y 吗？哦，原来你想要的是那个意思啊。但是
OK，
我的 y over x 对啊，就是最后能够画成这个东西啊。
对，画是一样的。的确，你讲的是对的，画就是一样。
所以其实有2种不同的对于 y against x 的理解是吗？一种是就是那个什么另一个同学算出来的，他是用 w 来替代那个啥，就他算出 y 和 x 之间的具体的关系是。
有一个
没有，那个是我们上面和下面。
你看一下那个同学了吗？那个同学的，什么叉来着？
这个哈，这个是上面一部分的下面一部分，加的是上面一部分，减的是下面。因为这个不是 function 吗？但是如果我们单看一般的话，它就是 function 了。所以这个如果我没有错的话，就是上面一部分和下面一部分，加的一部分跟减的一部分。
但是 y over x equals to tangent theta is actually also the 表达式吗 ？also equation of
哪一个？没有，这一个是 parametric curve， 就是说你是一个 particle 在上面跑的话是这个东西。这个是它的那个 curve， 就是整个 curve。
So this understanding is also right？
不是我要的，但是这个是另外一种解法。
Okay.
这
Surprise you. Okay. And I also have a question. So you mean that?
还是慢一点。慢一点。OK， 先开始先。
Okay, sorry.
OK， 没事，慢一点。Yep. Okay. All right. Hello.
The testing. Welcome back. We have the last hour. And we're just revising the linear algebra. Okay, so vectors. So vectors, I think the Chinese translation is good enough. What is the Chinese translation? So the important is yes. Okay, let me write down. Yes, good, correct. So I mean, you don't understand, never mind. But what I wanted to say is, what I wanted to say is, you don't understand, never mind. But what I wanted to say is very important. So this Chinese translation is very important. One word. The first word mentioned about direction. Second word mentioned about magnitude. Okay, exactly this is what the vector is. Direction and magnitude. Okay. Yeah. So for those who don't know Chinese, then today you learn 2 new words here. Okay. So this direction, this translation I like a lot. So this is very good because some of the mathematics term is quite weird in Chinese. But this is very good. This is exactly the perfect one. So magnitude is the scalar, yeah, or the scalars, and then magnitude is the, so the other one is the direction. So you have the direction and magnitude. So we will draw a head on our vector here to tell us which is the direction, and then the magnitude is the length. Okay, it's the length of the arrow. Hey, you see okay or not? Is the one sleeping okay? Are you okay? Are you well? Okay, because we just start new stuff, so you shouldn't be sleeping. Okay. Yeah, because this is just new. Okay, a vector from A to B, we will denote it as AB with a arrow. Okay, AB head. Okay, or we have bold alphabet or alphabet with head. Okay, these are all vectors notation. So you can see that we don't care. We actually don't care where the vectors start. Okay. They are equal as long as they are the same magnitude and direction. Okay, so we can translate our vector anywhere. Okay? We can translate vector anywhere. So we don't care about where it starts. Okay, okay, next. So sum of two vectors. If I want to sum u and v together, okay, we just draw a resultant vector here. Resultant vectors. Okay. And then if they are not connected, they are not connected, how? What do you do? Okay, how to add these two vectors together if they are not connected? Okay, you can move your v because they are the same vectors. Okay, anywhere. So in this case, then you can do your addition. Okay. And then it turns out that it satisfies the parallelogram diagram here. So this one so far okay. And then next is you can scale your vector. You just multiply by a scalar. So there are two operations you can do on vectors, right? One is vector addition, second is scalar multiplication. This is the two things you can do. Can you multiply two vectors together or not? No. Okay. Two Rn vectors you cannot multiply together. Okay. Rn vectors. Yeah. Okay. So you take the difference. Okay, you take the difference. How to take the difference? Okay. So this difference, right, is not something new. You should build it up from what we learned just now. Okay. There's no definition for minus. Okay. You don't know how to take difference, but you know how to add, you know how to multiply. So you need to write it as a form of vector addition and scalar multiplication. Okay. In this case, these terms make sense. Okay. You take v, multiply by -1, which means you switch direction. This is what we do. We already do it in the polar coordinate, right? R minus R, we go the other direction. And then you can add these two vector together. Okay, makes sense, huh? Actually, really, let me redraw this arrow here. Okay, what is u minus v? You also can thought it as this angle, this arrow here. Okay, u minus v is also this arrow. Okay, if the arrow that you add to v, you get u. This is another way you can think about it. Yeah. Yeah, this is just a revision for linear algebra so far. Okay, algebraic approach for vectors. Okay, so how you label the vectors? You label the point from the origin. Okay. So far, okay. A1, A2, A3. So really every point in your space, right? Define the vectors. Okay. By every point in the space define the vectors. Okay. So every point in the space, okay, you have a vector. You take every point, any point in the space, it defines a vector. Okay. So when are two vectors are equal? If they are equal, okay. If they are equal in direction, equal in magnitude, are the two vectors equal? Yeah. Equal as in the so we want two vectors to be equal if and only if every component is the same. So they start with 0, 0 and end at the same point. This is what we mean by equal vectors. Yeah. Yeah. Actually, we need to define what is equal vector first. So when do we say, yeah. So this one, right? So maybe perhaps we throw this equal here. Okay. So don't confuse us with two equals here. So maybe we talk about equivalent when they have the same magnitude and same direction, but equal on the north when it is exactly the same vectors. Okay, all component is the same. Okay. And then the zero vector is very important because this is the identity vectors when you add and do scalar multiplication. Okay, so this is what we mentioned just now. You can scale it. Okay, so when you scale a vector, what do? You multiply every component by the same number. Okay, the most obvious thing you can do. And then when you do addition, subtraction, you also add term by term. Okay, most direct way you can do term by term. Okay. Yeah. So this one is the difference between two points. Okay, so you can compute the distance by just taking the difference. So they create this name here, OB and OA. So it's just the vector from the origin. Okay, O to B, or maybe use another color. O to B, okay, and then O to A. Okay, and then you want to find the difference AB, B minus A. B minus A, right? Yeah, B minus A. So B minus A go which direction? Yeah, I think B to A. Oh, okay. You want A minus B, right? So this is B minus A. So A minus B is equal to minus B over A. So A minus B. Okay. Or you want
Wait, let me think. Wait. Oh, this one is b minus a. Okay, what would we ask just now? We asked a minus b, right? Okay, wait. Okay, I think the wrong part is this direction here. So if I want this, what do I want? I want b minus a. Okay, and then this one is equal to minus a minus b. Okay, so if you want to take a minus b, then you do the other direction. So the other direction is a minus b. Okay, so I find it easier to do addition. Okay, addition is easier. So a b minus a. So a b minus a, you get a plus b minus a, you get b. Okay, so this direction is b minus a. So this direction is a minus b because b plus a minus b is a. Okay, yeah. So instead of thinking difference, you can think of it as addition. Okay, yeah. So it's the same. Okay, so how to compute the length? This is also the Pythagoras theorem here. Okay, because you are taking difference between this point A with origin, so it's a1 minus 0 square, a2 minus 0 square, a3 minus 0 square. Okay, so it's the same as the Pythagoras theorem. This is the length. You take square root, and then I remember that this one is the inner product also, right? You guys recall this inner product? Yeah, inner product square root. Okay, I think we will mention again next, but next is unique vectors. So unique vectors means the unit meaning the magnitude is 1. So you need to divide your vectors by the length so that you get 1 length 1. So meaning if you compute this length again, okay, compute this length again, you get exactly 1. Okay, so next is the standard vectors. So when you guys see I, J, K, right, sometimes you just see it as a symbol. Actually, it is a vector in R3. So I is the 1, 0, 0, J is the 0, 1, 0, K is the 0, 1, 1, 0, 0, 1. So these are the standard bases in the R3. Okay, standard basis. Remember standard basis? Standard basis, okay. Okay, good. So you can see that these standard bases have they have length 1, so we call it a unique vector as well. Yeah, so far okay. Just what have been learned. So why we care about this unit vectors? Because they form a basis. That means everything in the vector space we can express as a linear combination of these three. Yeah. In particular, how you express it, you just take the coefficient in front of the I, J, K. Okay, so if you are given a point AI, A2, A3, the vector is exactly A equals to A1I plus A2J plus A3K. Right. So is this confused or not? So let me write out. So A1 times the vector. So they use column vector in this case. So we'll stick with a column vector. If you want to use, row vector. If you want to use column vector, also never mind. Also the same. Also the same. Okay. So what's this? 0, 1. Okay. So here scalar multiplication. So you multiply everything with A1. A1 times 0, you get 0. So you get A1 0 0 0 and so on. Okay. I want to show this example to show you the mechanics happening in our definition of addition and scalar multiplication. And then how you add these three vectors, you add term by term. So A1 plus 0 plus 0, and then A2, 0 plus A2 plus 0, and then 0 plus 0 plus A3. Okay. But why we call it algebraic? Because we don't need to keep writing out this vector here. Okay, what we can write out, we just write out some numbers with some variable. Okay, so this is called algebra. So that's why we put it in IJK form instead of writing as a vector form. Okay, so far same. This one easy. Skip. Okay, skip. Okay, make sure you do it. Make sure you do it. Then you check answer. If you skip, right, I also have to spend time writing out. Yeah. So we both doing the same work. Okay, next, this abstract definition here, theorem. So, what does it mean here? So this means that vector addition is commutative. Okay, vector addition is commutative, meaning, I don't care how you add them. You can add A with B, you also can add B with A. Okay, so switch position, doesn't mind. 2 is associative. Okay, so if you want to add 3 numbers together, how? Okay, because I only tell you how to add 2 numbers. 3 numbers how to add. So you add the first 2 first and then add with the last one, or you add the last 2 first and then add with the first one. 3 is the identity. So vectors addition, additive identity. So anything that add to a vector, you get back yourself. That vector is the 0 vector. Additive identity. 4 is the inverse. So, and what is the vector that you add to A, you get 0 is minus A. Additive inverse. And then next is the scalar. So scalar multiplication, scalar associativity. Okay. So you can, if you want to multiply 2 scalar, actually you can multiply the scalar first, then multiply. 6 is scalar distributivity. Okay, so distribute. So scalar multiplication can distribute over vector addition. So you can add vector first and then you multiply scalar, or you multiply both vector with scalar and then you do addition. Or if you want to multiply addition of scalar, you also can distribute your scalar. This is the first distributivity. This is the second distributivity. Okay. Okay, 8. 8 is 1 times A equals to A. So this means if you have a scalar 1 multiply A, you get that A. This maybe sound a bit stupid, but it's kind of important. Yeah. Yeah, a bit stupid, but kind of important. Yeah. 9. 9 is if you scale a vector and then you can just compute. If you want to compute the length of the scale vector, you just take the scale factor, take the modulus, and then multiply with the length of A. Okay, because length is always positive. There's no negative length. Okay, if it is negative, you cannot see the item. Okay. Okay, next. Okay, so we come back to this dot product again. I think we should do one example here later to check everyone is on the same page. So the dot product of 2 vectors is exactly defined by you take the multiplication of the corresponding component and then add them all up. Okay. So example, so you have 0, 1, 1 and 2 minus 1. Okay, A and B. So you want to take the dot product. What do you get for the first term? Okay, I like column better, so I write column. So what's the first term here? 0 times 2 plus 1 times minus 1 plus minus 1 times 1, which is equal to -2. Okay, so far okay? Yeah. No? Wrong answer. Wrong answer. No, right? -2. Oh, I copied the wrong answer. I copied the wrong question. Okay. So this one is the 1, 1, which is 0. So this means what? These two vectors are orthogonal to each other. So they form a 90 degrees. Yeah, later we'll come back again. Don't worry. We're just doing revision. Okay, we'll talk about this again. So if something dot together is 90 degrees. Okay, so far everyone. Okay, I think dot product you should learn because sometimes we need to do modification, normalization. Then you need this dot product. Yeah, normalization. Okay. Property of dot product, you can see that. Okay, dot product, right? Just now we mentioned that we cannot multiply two vectors together. But see, we multiply two vectors together now. But what you get is not a vector, it's a number. Okay, it's R. So you go from R2 times R2 to R, or R3 to R3 to R. Okay, you get a number out instead of a vector. So we call it a dot product. It's a special product. Usually when we talk about product addition, we want to stay in the same space. But now we go up from R2, we go into real numbers. So dot product here is good, it's commutative, it's also associative. Okay, we also can distribute and then so on. We can compute the length. The number 5 property, right, is the definition, I think. Okay, this is what we taught just now. Hold on. 4 is a 0. 4 is very important. You see, 4 is a 0 vector dot with a vectors. You get a 0 number. Okay. Okay, it's not, yeah. 0 vector dot with a vectors, you get 0 number. Okay. Okay, next. So there's a theorem here. I think we prove it in the linear algebra. I remember I did this in my course. So what is A dot B really? So if it is in Rn, we can think of it as a product of the length of A and B and the angle between them, cos theta. Okay. So this two information is stored inside this dot product here. Okay. So just now we get A dot B is 0. So this means cos theta is pi over 2. Okay. So theta is pi over 2, then cos is 0. Because AB must be non-zero. Okay. If you're taking a non-zero vectors. So when A dot B is 0, then cos theta must be 0. So when is cos theta is 0? Is when theta pi equals to pi over 2 or 3 pi over 2. But in either direction is pi over 2 to each other. So it's 90 degrees. Okay. And how about do this? Want to do this? Or maybe not. Let me see the example tedious or not. Okay, maybe not because this not nice. Okay. Maybe left as example. Okay. Keep going. Still revision. Okay, so when two vectors A, B are perpendicular, if and only if A dot B is 0. So just now we mentioned about this. Okay, maybe we do this example then. Show that 2i plus 2j minus k is perpendicular to 5i minus 4j plus 2k. Yeah, try do this. Try do this. How to show these two vectors. Yeah, how to compute. Actually, I told you what to compute, but how to compute it. How to compute this? First term is 2 times 5 plus minus 2 times minus 4 plus minus 1 times 2. What do you get? 0. Okay. So by theorem above it is they are perpendicular. Is it theorem? Huh? What? Since let me call it A and B. Since A dot B is 0, then it what's that? It is orthogonal to B. Okay. Depend on what convention you like. You also can write it in the form of 2 minus 1. If you want to see it in this way, okay, also can. Yeah, so depend on. So you, in your mind, you should be able to switch between column vectors and this ijk. Okay. Okay, after dot product and is the cross product. Okay. So why we have different products here? So cross product, we produce product. Sorry, produce vectors. Okay. So in cross product, we produce vector. Okay. Dot product, we produce scalar. So anyone recall what is the notation on this? What's this notation here? Augmented? Not quite. What's this notation here? Determinant. Okay. So you are finding a determinant of a 3 by 3 matrix. Okay. So determinant of 3 by 3 matrix, you can use core factor expansion. Okay. So this is the core factor expansion formula here, where you expand across the first row. Okay. So you take I, and then you calculate this minor here, A2 times B3 minus A3 minus B2. Okay. And then J, so plus minus plus, right? So minus J, and then you compute the minor here, which is A1 B3 minus A3 B1. And then plus the last one, then you compute the minor here, A1 B2 minus A2 B1. Okay. But to set up this 3 by 3 matrix here is quite crucial. If you set it up wrong, then you will compute the wrong cross product. Up to sign. Okay. How about do this exercise here? Okay, I just want, try and do this exercise here. See if you can use this formula. Okay. Because this is a skill that you need later. Okay, so set out the 3 by 3 matrix first. And then compute the core factor expansion. There's two things I want you to compute. Compute A cross B and B cross A. Two direction I want you to compute. Just try compute. Yeah, just write out formula for the first one. Can anyone tell me what do you get for A cross B? 2 1, 0. Good. How about B cross A? Have you done? -2, -1, and 0. Yeah, if you go do it, it's -2, -1, and 0. And what can you see? Yes, so A cross B is the negative of each other. So how do you think about it? So if you take cross product follows the right hand grid rule. So A cross B, you get vector upwards. If you take B cross A, you get vector downward. Okay, so it's an up-down relation. It's a up, yeah. Okay. Okay, the rest you do as exercise. Actually, in this cross product, right, do you notice some weird thing inside this 3x3 matrix? I and J are actually not number. Okay, but A, I, A2, A3, and B are numbers. Okay, so there's something going on here. If you're interested, you can look for the derivation, how we get this formula. Yeah. Okay, next. So next, so what's the interpretation for cross product? A cross B is perpendicular to both A and B because it's the right hand grid rule. And then right hand triple, okay, this is the right hand grid rule. So A, B, and A, the vector A cross B from on the right hand, the triple. Right-handed triple mean you have a 3-dimension. Yeah, 3-dimension. Okay, they form 3-dimension. And then if you see, you also can bounce theta out from cross product. Okay, but cross product you obtain another vector, right? Okay, so how to get real number? You compute the length again. Okay, so the length of a cross product is equal to the product of respective length of A and B multiplied by sine theta. Okay, just now we have cos theta, now we have sine theta. Okay, so this is another way you can compute angle between A and B. Okay. So two vectors are parallel if and only if A cross B is 0. Okay, so it's parallel if A cross B is 0. So if they don't form an angle, you cannot do the right hand thingy. And then you can compute this A cross J is K, J cross K is I, K cross I is J. Okay. You also can think of this as the right hand rule. So I cross J, you get the Z axis, and then Y axis cross with the Z axis, you get X axis, so on. Okay. And then similarly, you have these properties here, but not the difference here. You see, you don't always commute, you know. When it is cross product, right, it anti-commute. So when you commute, there's a sign pop up. Okay. And then you still have associativity. You see here, you don't distribute across 2 anymore. You just distribute across 1 of them. Okay. This one still have multiply 0, get 0. So this is this is all 0 vectors. And then A cross A is 0. And then this one distribute. And then here also have some difference here. There's some difference here. So when you multiply 3, when you do cross product of 3 vectors, right, they're no longer associative. They become something else. Okay. Yeah. You can show it algebraically if you want. You can show try show this property in R3. Okay. How about we do one of the exercise? Okay. Let's do one of the exercise here. I'm not sure this is required to learn or not, but they did it last year. So let's try and prove which one do you want to prove? Maybe do the first one. Okay, and then we will end here. So try do the first one. So try just now we compute an example, right? We just compute an example that A cross B equal to minus B cross A. But now we want to show it in general. So let A equals to A1, A2, A3, or B equals to B1, B2, B3. Okay. So if you want, you can write in different notation. For example, A1I plus A2J plus A3K, or you want to write it as a row column. Up to you. Okay. All right. So let's compute A cross B. Okay. So what's A cross B? So by definition is AJK and arrange A1, A2, A3 on the second row, and then third row A B1, B2, B3. And then what's the formula? A2, B3 minus A3, B2, I, what else? Plus, plus what? Plus, sorry, it's minus J, and then A1, B3 minus A3, B1, J, and then plus, so plus, what else? Plus something times K, and then A1, B2 minus A2, B1. So do the four-factor expansion. Okay, from here, maybe it's hard to see what is minus B over A. Maybe we do backward. So this is one of the tips. So you do backward. Okay. So let's do backward and then see we can join in the middle or not. So B1, B2, B3, and then A1, A2, A3. Okay. So we put a big minus sign in front first, and then we compute what is IJK. So what is I? B2, A3 minus B3, A2 minus J is what? B1, A3 minus B3, A1, and then plus what is K? K is B1, A2 minus B2, A1. Okay, so let's see these two agree or not. Okay, so let's check I by I, J by J, and K by K. So I is what? A2, B3 minus A3, B2. Here, B2, A3 minus B3, A2. Okay, but if we multiply a minus sign, they become the same. Okay, because multiplication of scalar is commutative, so this one is just equal to A3 times B2 minus A2 times B3, and then you swap the minus term from this extra minus here. Okay, so similarly, you can do it for J and K, and then you see that they are actually the same. Okay, so if you want to show for the rest of this property, right, you just follow the step here. So if there's ABC, you need to take another C, and then you do all these and then show that left and right is the same. Okay, yeah, there's nothing tricky here. Okay, so next lecture we will use these two, and then we will find plane in 3D and so on. Okay, plane in 3D. All right, so see you not tomorrow. Thursday. Okay, see you on Thursday. 8 o'clock.